So, you're prepared to see the consequences of the mission? A huge number of space rocks circle with us around the sun consistently, from some as small as the size of your clenched hand to others as large as vehicles. The danger of a crash at speeds of thousands of meters per second is genuine. This is the reason NASA sent a spacecraft to one of the nearest space rocks to Earth on a mission to gather samples and predict the chances of a collision. The samples returned in late 2023, and researchers have been stunned at the results their investigation has produced. In fact, specialists are saying that life on Earth could have come from these space rocks. What is in these space rock samples? What results did NASA find from their investigation, and what are the possibilities of the space rocks slamming into Earth? Join us in this video as we check how NASA just opened the biggest space rock sample. Our universe is a quickly expanding and dynamic center of activities. We live on a piece of rock and metal circling around a giant ball of gas and fire, alongside other planets in a cosmic system that contains countless other planetary groups like our own. This means there are billions of things occurring each second that we have little insight into and might very well never know about. According to researchers, since the Big Bang, the universe has been hurling itself outward for billions of years. Within this expanse are certain celestial objects that act as mementos, giving us a glimpse into our universe, its operations, and its future. We call these objects space rocks. Despite being often relegated to the realm of sci-fi disaster films, space rocks have been shown to be immensely significant in our planetary system. These extra pieces of rock and metal from the formation of our planetary system play a fundamental role in our understanding of the past, present, and future of both our planet and its neighboring celestial bodies. To comprehend this, envision the solar system as a gigantic building site. Approximately 4.5 billion years ago, you would expect to see debris and flying rocks everywhere, which is why everyone wears a protective helmet on these sites. Space rocks are the extra garbage, the cosmic rubble that never fully formed into planets. By examining what they are and what they contain, researchers can gain valuable insights into the early stages of our solar system. Many astronomers see space rocks as time capsules, preserving the chemical makeup of the primordial disk that birthed the planets. By examining their components, researchers can understand the building blocks that formed our solar system, which in turn provides a brief look into the raw materials that went into making Earth and its neighbors. Some space rocks ultimately fall to Earth as meteors. By studying these fallen rocks, researchers can peer back in time to figure out Earth's early history. Some meteors are believed to be remnants of protoplanets, celestial bodies that never fully formed into planets. By analyzing their composition, researchers can recreate the turbulent time of planetary formation and develop a more balanced timeline of the events that led to the formation of Earth. There is also a theory that space rocks delivered the building blocks of life to Earth, and they may hold the key to unlocking the mystery of life's beginnings. Space rocks, especially those rich in organic compounds like carbon and water, are believed to have crashed into Earth in its early days. These impacts could have supplied essential components required for life to form, such as amino acids, the building blocks of proteins. While some space rocks hold the potential for life, others pose a real danger. Large space rocks on a collision course with Earth could trigger devastating global events, as evidenced by the Chicxulub impactor, believed to have wiped out the dinosaurs. To deflect this threat, space agencies like NASA actively track near-Earth objects, NEOs, and develop strategies to avoid them if necessary. However, not all space rocks are bad news. Many contain valuable resources, such as precious metals like platinum and nickel, that exceed the deposits found on Earth. As space exploration advances, specialists believe that space rock mining could become a viable source of materials for future space endeavors and potentially even supplement our diminishing resources on Earth. This potential is why NASA has initiated several missions to either divert space rocks or recover samples from them in space. The latest of these missions is OSIRIS-RX, which began in 2016. So, what is OSIRIS-RX? OSIRIS-RX is a daring space rock sampling mission. It was launched on September 8, 2016, for the near-Earth asteroid named Bennu. The objective was to recover samples from the surface of the asteroid and return them to Earth. After this, it would then embark on a long-term mission to study the asteroid Apophis. Upon arriving at Bennu on December 3, 2018, OSIRIS-RX took detailed measurements of Bennu's shape and mass before successfully descending to collect samples from the asteroid's surface on December 31, 2018. The samples were returned to Earth on September 24, 2023. Of all the asteroids in space, why Bennu? Among the many near-Earth objects circling within 120 million miles of Earth, Bennu was one of fewer than 200 whose orbit was well and closely aligned with Earth's orbit. According to researchers, this asteroid circles the Sun every 400 days and comes extremely close to Earth approximately every 6 years. Bennu is also large enough for a spacecraft to land safely on. It is about 1,650 feet wide. Additionally, Bennu is believed to be rich in carbon-based material, which is significant. Space rocks that may have delivered water and organic material to Earth, helping to kickstart life, would have been similar to Bennu. Bennu's close orbit also makes it a potentially hazardous object for Earth. However, NASA currently estimates that the risk is relatively low. The likelihood of the asteroid crashing into Earth through 2300 is calculated at 1 in 1,750. If it were to crash into Earth, the impact wouldn't destroy the planet, but it could cause significant damage wherever it lands. Scientists say that an asteroid the size of Bennu would likely devastate the surrounding area upon impact, but it wouldn't lead to mass extinction. Still, the preemptive measures provided by the OSIRIS-RX mission could help researchers prepare long before an impact occurs. One such measure could be to divert the asteroid entirely using the kinetic impactor method, as demonstrated by NASA's DART mission. The DART, Double Asteroid Redirection Test, mission was completed on September 26, 2022, where a spacecraft was successfully collided with a small asteroid called Dimorphos to change its orbit. The mission was a huge success, with NASA officially reporting on October 11, 2022, that DART shortened Dimorphos' orbit by an impressive 32 minutes, exceeding previous estimates. So, what did OSIRIS-RX find on Bennu? NASA states that the samples gathered were found to contain abundant water and carbon. This is significant news, as it provides further evidence for the hypothesis that life on Earth originated from space. This announcement came when NASA gave the public a first brief look at what researchers saw inside the OSIRIS-RX space apparatus container. As indicated by NASA overseer Bill Nelson, this is the greatest carbon-rich space rock sample ever returned to Earth. Carbon represented nearly 5% of the sample's total weight and was present in both organic and mineral forms. Nelson also added that the water was locked inside the crystalline structure of dust minerals. The discoveries were conveyed through a preliminary investigation, which included examining the sample with electron microscopy, X-ray computed tomography, and more. Specialists say that the preliminary results highlight the probability of further discoveries that could support the hypothesis that early Earth was seeded with the ingredients for life by cosmic objects such as comets, asteroids, and meteorites that bombarded the young planet. NASA stated that the mysteries held within the stones and dust from the asteroid will be studied for years to come, offering insights into how our solar system was formed, how the precursor materials to life may have been present on Earth, and what precautions should be taken to avoid asteroid impacts with our home planet. Another senior NASA researcher, Daniel Glavin, mentioned that early examination found the material to be rich in organics. According to him, this stuff is an astrobiologist's dream. However, the examination was not completed on the sample held inside the primary storage container. In fact, nobody at the announcement event got to see any of the samples firsthand. Photographs and recordings of the asteroid pieces are said to still be behind secured doors in another lab at the Space Center, accessible only to researchers in protective gear. The pictures of the sample showed a loose cluster of small, charcoal-colored rocks and dust found in the outer part of the spacecraft's sample collection canister. Researchers were still carefully working on dismantling the canister containing the majority of the sample. According to Dante Loretta, head mission specialist at the University of Arizona, the initial sample of overflow material was quickly inspected. She stated that researchers also found iron minerals, such as iron sulfides and iron oxides, which are indicative of formation in a watery environment. Upon opening the canister, researchers uncovered that Bennu contains a repository of a mineral called magnesium phosphate. According to specialists, these bright white particles are extremely rare to see in astromaterials. It's no surprise that we initially thought this might be a contaminant, said Jessica Barnes, an associate professor at the Lunar and Planetary Laboratory, LPL. Barnes is leading the phosphate investigation in the return sample. Speaking at the Lunar and Planetary Science Conference, LPSC, in Texas, she noted that there are no good chemical analogs of the mineral on Earth, either because it is too delicate to survive the fall to Earth or because it disappears shortly after its presence in Bennu can be used to infer various episodes of geological activity on Bennu's parent body. She added that the samples also show the inevitable presence of glycine, which is the simplest amino acid and an essential component of proteins, as well as other water-bearing minerals including carbonates, sulfates, olivine, and magnetite. This suggests that Bennu's parent body experienced multiple water-related events before it broke apart to form Bennu. Other researchers studying the extraterrestrial samples found abundant water-altered compounds called phyllosilicates, along with a rich assortment of other organic and hydrated minerals. Phyllosilicates are primarily associated with water and meteorites, and they might have been the carriers of organics and water that researchers suspect were delivered to Earth early in its history. In a series of talks at the LPSC, the mission team reported that the rock inventory so far also contained various hydrated minerals and evidence of space weathering, which would be expected from an airless rock that is billions of years old. "It's a beautiful sample," said Sarah Russell, a planetary scientist at the Natural History Museum in London, who analyzed a small portion of the sample. She added, "I would say it's unlike any meteorite in our collection." Another team member, Tim McCoy, a curator of meteorites at the Smithsonian National Museum of Natural History in Washington, D.C., said that, unlike most meteorites whose surfaces are altered by years of exposure to Earth's atmosphere, pieces of Bennu are the most pristine space rock researchers have ever held. "I can't tell you how refreshing it is to see samples where everything isn't altered to sulfates and all kinds of grime. You're seeing it literally the day it fell. It's wonderful to see something that new." Many of the recorded rocks from Bennu are humic rocks with a rough, sandpaper-like surface, according to colleague Andrew Ryan, a research scientist at LPL at the University of Arizona. Overall, the mineral compositions confirm various expectations derived from remote sensing data collected by OSIRIS-Rx as it approached Bennu. "We got it right with the remote sensing," said Harold Connolly, a geologist at Rowan University in New Jersey, noting that this directly feeds into how we are analyzing the sample and testing our hypotheses. So far, the investigation has been consistent with the leading theory that Bennu broke off from a much larger asteroid around 2 billion years ago. For instance, the latest examination shows Bennu's rocks are covered with impact-related breccias, which are rock pieces loosely held together like stones in concrete. These breccias probably didn't form on Bennu, they formed on the parent asteroid and then became incorporated into Bennu. It is still unclear exactly when they formed. "We're still in the very early stages of this extremely meticulous work," McCoy stated. These discoveries were made possible by the 5 instruments on board the spacecraft, whose purposes were to capture and analyze the asteroid material in the greatest detail. REX's apparent and infrared spectrometer overs its responsibility is to chase after organics and different minerals by estimating apparent and close to infrared light. Then you have the OSIRIS-REx Warm Emanation Spectrometer, OTS, utilizing the warm infrared to take Bennu's temperature and plan mineral and compound overflows. This spectrometer works with others to map Bennu over a scope of frequencies to select the best site for gathering tests. The third instrument is the OSIRIS-REx Camera Suite, OCAM. This is a 3-camera suite that plans Bennu. Polycam, the biggest, obtain the main pictures of Bennu, taking them from 1.2 million miles out and capturing high-resolution pictures of the sample. The second camera, MapCam, chased after satellites and residue tufts around the space rock, planning it in variety and taking photos to make geographical guides. The third camera, SAMCAM, reported the assortment and capture of the sample. The fourth instrument is the OSIRIS-REx laser altimeter, OLA, whose responsibility is to check the whole surface of Bennu and send back information to create highly accurate 3D models of the space rock surface. According to researchers, one of the two Canadian-built lasers failed during the primary mission. However, it continued to work beyond its expected lifetime and gathered all the data required for OSIRIS-REx to land. The last instrument is the regolith X-ray imaging spectrometer, REXIS. This spectrometer was utilized to concentrate on X-ray discharges from Bennu and assist with the formation of a map showing the overflow of different components on the surface. Dissimilar to other imaging instruments, REXIS analyzed the composition of the space rock at the level of individual nuclear components. The OSIRIS-REx mission doesn't end with Bennu. According to NASA, OSIRIS-REx is supposed to connect with Apophis in 2029. Apophis is another potentially hazardous space rock that was recently eliminated from the Earth Impact Risk Table. This table monitors space rocks where an Earth impact cannot be precluded by NASA. Apophis has been considered not to be an issue for at least the next 100 years, based on further advanced reproductions of its movements through space. On Friday, April 13, 2029, Earth will have a close encounter with the space rock that will see it come within only 19,000 miles of the planet. This is closer than most geostationary satellites. Previously, researchers had determined that Apophis had a tiny chance of hitting Earth during a flyby in 2068. However, the reassessment of its risk in 2021 showed there is no danger at all to worry about. However, with the space rock coming so close, NASA decided to use the opportunity to have a sound and unasked rocket available for a flyby. NASA announced in April 2022 that it would divert OSIRIS-REx to take advantage of the encounter and rename the spacecraft after it drops off Bennu samples at Earth in 2023. The spacecraft's name was changed to OSIRIS-APEX, and it is expected to arrive at Apophis in 2029. Besides one of the transmitters of OLA, the instruments on the rocket are sound and working accurately. This will allow the new OSIRIS-APEX mission to perform its tasks. The rocket is supposed to look at Apophis for a considerable length of time and get close enough to examine the space rock thoroughly. It is important to note that OSIRIS-REx is not the only space rock mission to return tests. While it is the first to return samples to the U.S., Japan has already shot ahead with two similar missions. In 2010, Hayabusa became the first spacecraft to bring back a sample from an asteroid. A successor Japanese sample return mission, called Hayabusa 2, did the same with asteroid Ryugu in 2020. NASA's Dawn mission is another example. It visited the asteroid Vesta before continuing on to the dwarf planet Ceres. However, this is in contrast to the OSIRIS-REx mission, as the Dawn mission didn't bring samples back. Its visit was for different purposes. Past its work on Bennu, it is expected that OSIRIS-REx will also help astronomers study the Yarkovsky effect on asteroids. This phenomenon occurs when heat from the sun gives a small push that changes the trajectory of an asteroid or other object. Although the push is negligible, it can accumulate over time, helping to change how an asteroid travels. So, while exploration and investigation are ongoing to figure out what Bennu truly looks like and what it contains, researchers are looking to alleviate any concerns about the likelihood of close contact or even an impact with Earth. This means we should be excited rather than anxious about what asteroids hold for us and how this will assist in establishing our understanding of how life came to be on our planet and the possible fate of our planet.